Hello, so today we're going to be looking at the chain rule as it applies to calculus. So when we look at the chain rule, it is actually a formula for computing the derivative of the composition of two functions. So say if f and g are functions, the chain rule will express the derivative of their composition f of g. So we can all put this into a form that we'll understand. So pretty sure we've all seen this form. F of g of x prime equals f prime of g of x times g prime of x. So now what we're going to do is show you what an example of the chain rule would look like and when we would use it. So say we're asked to find the derivative of 8x to the 3 plus 5x squared minus 2x to the 5th. So when we look at this, we would probably usually see it as only one function. But here we can see that when we're looking at the chain rule, we're taking the derivative of the composition of f of g. So we can see this kind of looks like two functions. We can represent this 5 as f and all of this as g, the function. So what we're going to do is take the derivative f of g. So we're going to bring the 5 around to the front and multiply that by our g. So it's going to be 5 times 8x to the cube plus 5x squared minus 2x. We're going to make that to the 4th because we know in our derivative laws we have to do x minus 1 to the exponent. Now what we're going to do is multiply this by the derivative of our g. So that's going to be 24x squared plus 10x minus the derivative of 2x is just 2. So there we have our chain rule for this example, and this is how we would leave it if we didn't need to simplify it. This is what it would look like. And so we can do one more example just to make sure we know what we're doing. So say we have to do the derivative of x to the 4th plus 9x squared minus 2x to the 4th. So we look at that again. We bring down our f, so we can do 4 times x to the 4th plus 9x squared minus 2x to the 3rd, and multiply that by 4x cubed plus 18x minus 2. And there we have our couple examples of the chain rule as it applies to calculus.